A car is travelling at a speed of 10 meters per second around a bend, and the road is banked at an angle of 30 degrees. And we're asked to write the normal force in terms of these variables. Well, taking a free body of the car and drawing all the forces acting on it, and I've drawn them through the centre of mass of the car for easier visualization. But we know that the contact forces act at the tyres. So if we resolve the forces into horizontal and vertical components, and recognizing that these angles are equal to the banking angle of the road, and applying Newton's second law in a radial direction, and in the vertical direction, and now if we multiply the first equation by sine theta and the second equation by cosine theta and add the equations together, well, we eliminate the friction force. And using the trig identity, this is equal to 1, so you can solve for the normal force. And to obtain a friction coefficient, we can use the relationship between a static friction force and the normal force. So having obtained the normal force from this equation, you can substitute into either one of these equations to obtain a static friction force, and then solve for the coefficient of static friction where the car does not skid.